PCB design for beginners. Whether you're just starting in the world of electronics or you've been doing it for years, there's always something new to learn. Design, while it can seem complex at first, really boils down to some simple rules and techniques that will help you to save time and money while making your projects run more smoothly. There are plenty of steps and processes involved in the PC design process, and as such, there are many things that you need to know in order to create an effective design. This guide will help you understand how to go about the process of designing your PCBs and take you from beginner to expert. What is a printed circuit board, PCB? A PCB is a self-contained module of interconnected electronic components found in devices ranging from common beepers, pagers, and radios to sophisticated radar and computer systems. The circuits are formed by a thin layer of conducting material deposited, or printed, on the surface of an insulating board known as the substrate. Layers of insulation called traces carry electrical currents between various points on the board. Capacitors, resistors, inductors, semiconductors such as transistors and diodes, and connectors may also be attached to the surface through holes that have been punched into it with a special machine called a drill press. All parts on the board must have features small enough so that they can fit inside this drilled hole with no problems at all. One major aspect of a design is to make sure there is plenty of room around each component to minimize noise caused by electromagnetic interference. In addition, great care should be taken not to put too closely spaced components on top of one another because this could lead to one component interfering with the other's signal voltage. What are the parts of a PCB? A PCB is made up of a few different parts, such as the board, the surface finish, the solder mask, and the silk screen. The board is the green part that everything is attached to. The surface finish is the layer that helps protect the copper from corrosion. The solder mask is the green coating that helps prevent short circuits. The silk screen is the white print on the board that has the logo and part numbers. There are many more parts that go into a PC board, but these are the basics. The materials used in building a PCB will vary depending on how they will be used. There are 4 main types of boards, including paper-backed FR4, epoxy-coated FR4, Kapton, and ceramic substrates. Paper-backed boards are usually cheaper because they don't require special equipment to make them, whereas other boards may need expensive machinery or specialized chemicals during production. Epoxy-coated boards can be damaged by water and UV light, while Kapton doesn't corrode as FR4 boards do. Ceramic boards can also get damaged easily. Paper-backed FR4 is often used in low-volume production environments with surface mount technology, SMT, devices such as resistors, capacitors, diodes, integrated circuits, and inductors. How do I begin? Maybe you've designed a few simple circuits by hand and are ready to take the next step. Or maybe you've never designed a circuit before but have some experience with computer-aided design, CAD, software. Either way, this guide will teach you the basics of PCB design. The first thing you'll need is an electronic CAD program. The most popular programs are Eagle, KiCad, and Altium Designer. They each offer trial versions that let you get started without investing any money upfront. You can download them from their websites or find them on your operating system's app store. Choosing the right software. When it comes to PCB design software, there are a few different programs you can choose from. But which one is the best for you? It depends on your needs and what you're looking for in a program. If you're just starting, we recommend trying out a few different programs to see which one you're most comfortable with. Once you have a better idea of what you need, then you can start narrowing down your options. A good example of this would be if you needed to design circuits with specific electrical requirements or desired material properties. You should also see if you work with a team of people on projects and want them all using the same system. The biggest thing when choosing a PCB design software is making sure that it meets your needs as well as your budget. If you want to learn how to design your PCBs, you'll need to know how to use a CAD program. These design programs are used by designers to create electronic schematics and layout boards. The schematic consists of all the components needed in order to power the circuit, while the layout shows where each component should be placed on the board. Two popular CAD platforms include Eagle CAD and KiCad. Both are open source but have different strengths. Eagle CAD is known for its intuitive interface, while KiCad has better compatibility with older hardware. One important thing to note is that every time you make changes to the schematic or layout, they need to be resynced with one another. If they aren't, then small mistakes can easily turn into large ones later on. To avoid this problem, check the sync settings at the top of the screen before making any modifications. Learning about board etching and printing before you can start creating your PCBs, it's important to understand the basics of board etching and printing. Board etching is the process of creating electrical circuits on a substrate, usually using a photochemical process. This is typically done by first creating a master template, which is then used to create a negative film. The negative film is then used to create a resist-coated board, which is exposed to UV light and developed. The exposed areas are then etched away, leaving behind the desired circuit pattern. In contrast, PCB printing is often performed in what's called surface mount technology, SMT. In this type of manufacturing, components are placed onto a flat surface, like sometimes copper coated with solder paste applied between them to connect them. A final coating may be applied before the SMT assembly undergoes reflow soldering. Once finished, the boards can be separated from one another and packaged. There are many different types of PCBs, including single-sided boards, double-sided boards, flex boards, and rigid flex boards that may also be utilized. Choosing the right kind of board depends largely on how they will be used, as well as cost factors such as materials and labor requirements. For example, flex boards are less expensive than rigid flex boards because they use flexible plastics rather than stiffer fiberglass or FR4 substrates. However, the trade-off is that these boards cannot be mounted to something. Single-sided boards are also cheaper but may not offer the same level of protection against ME interference as other types of PCBs might be able to provide. Double-sided boards, on the other hand, offer more protection against interference but require more work when designing them due to routing limitations. They also take up more space than single-sided boards, meaning fewer components can fit on each board. When deciding on the appropriate PCB type for your project, it's important to weigh all of these considerations carefully so that you make an informed decision about what is best for your needs. Tips for successful board prototyping: 1. Use quality materials. This is important because you want your prototype to look and feel like the final product. Plus, it will help ensure that your board functions correctly. 2. Make sure your design is clear and concise. A well-designed board will be easier to troubleshoot and will save you time and money in the long run. 3. Pay attention to details. This includes things like trace widths, spacing, and clearance. The smallest of details can have a big impact on the success of your PCB. 4. Create a schematic. If you are not experienced with schematics, there are plenty of resources online to help guide you through it. Remember that your schematic should match up with what's on the PCB and vice versa. For example, if you plan to use LEDs on your board, then make sure they're included in the schematic. You'll also need to decide which type of LED, transparent or non-transparent, you want, so you can include that information as well. Keep these 4 tips in mind when designing your next PCB and get ready for a successful prototyping experience. 5. Build a prototype from scratch. We know that building your first PCB from scratch can be intimidating, but there are quite a few options out there for those interested in learning how to build their boards. So far, this guide would be enough for those who are new to PCBs, would like to know more about design or printed circuit board assembly. Email us at sales@pnconline.com.